Hi, I just got done leveling a ballistic pendulum. What is that? Well, let's find out. Alright, so you see that bubble is pretty well centered. It's hard to get lined up because there's some things in the way here, but when you look at it, it's nice and centered. This is the ballistic pendulum. And it's a pretty simple apparatus. It's got a heavy block here, catcher, you know, just strung up so it's able to act like a pendulum, swinging back and forth freely. And what happens is we take a ball, a metal ball, and we stick it on the end of this spring gun, and it'll shoot the ball into the catcher. And it's kind of got some rubber inside of it to make it grippy, if that's a word, grippy. And it'll catch the ball, and when it ball shoots into the pendulum and it gets caught, the pendulum goes back, of course, and pushes our angle marker to a certain degree, which we will measure, and from that be able to figure out how high this catching block was pushed just by the energy momentum of this little metal ball. So I need to do some test firing to make sure that the catcher can successfully catch the metal ball, because this thing is just attached with strings and little adjusting knobs up top. Sometimes it's hard to get this thing aligned just right so that the ball is caught very efficiently. So let's do the test fires. Okay, let's try it from this angle here. Pull the spring gun back. There, second notch. Still level. Get the ball here. Stick it in the little end of the cannon, end of the gun. Hold the catcher steady. And test fire one. Okay, it was successfully caught. Okay, well, to get the ball out, I have to take this little plunger here and stick it in the back of the catcher, push the ball out. Alright, before we do all the shots and angle measurements, we need to get the mass of the ball and the mass of the catcher. And we also need to get the height of center of gravity. CGH is height, CG is center of gravity initial. And so we basically need the change in the height of the center of gravity. So we're going to measure the initial height in a minute. First, let's get the mass here. So here's my little holder for the ball. I'm going to zero that mass out. Add the ball. And there you go. Write down the mass of the ball. Okay. Okay, next I got to measure this catching block. Just leaning the whole pendulum over so the strings aren't supporting any of its weight. And that's the mass of the catcher block. 79.3. Well, 79 point something. 79.29. There we go. We'll take it. Alright, I said 79.29. Okay, 79.29. Okay, next we need to measure height. So we can figure out the change in height of the catcher. That's what we're interested in, is the change in height of the catcher. And now this angle bar, a red bar coming down, I have a little tape marker on there, black. I colored the tape a little black. And so we measured to the bottom of that little tape marker, right above 8 centimeters. Okay, so we should be able to get 8 point something, and you can estimate to the third significant figure, the second decimal place, on that initial height. You guys are going to make the angle measurements after each shot, and you write them down here on the third table down here, the Cynmar pendulum. That's what this one is. When the catcher moves from the ball, you're going to push that metal bar up, and you will then record the angle that the metal bar is making. And so say that's 15, 16, 17, 18, 19, 20. And you can estimate in between those, if you measure to the center of the metal bar, that tenths place on the angle here, so we can get 3 significant figures. Okay? Okay, now it's time for shot 1 to make the measurement. Get this spring gun loaded. Second shot. Well, this is the first shot. It was on the second notch of the spring gun. Starting on 0. For the angle bar. And 3, 2, 1, fire. That was a dud. It did not catch the ball. Dang it. Okay, let's try this one. This is going to be a redo of shot 1. Okay, got the spring gun loaded there. And 3, 2, 1, fire. Okay, it caught the ball that time. Make your angle measurement. And I'm going to get the ball out of the catcher here. Alright then, let's try shot 2. Pull the spring gun back here. Second notch. Load the ball. And ready, set, fire. Okay, caught the ball. That was a successful shot. Make your angle measurement there. Looks like it's pretty spot on, 19.5, or I'd say 19.6 degrees. Okay, now I gotta eject the ball from the catcher. And reset the angle bar. And pull the spring gun back for shot number 3. Second notch again. Load the ball. Ready. Aim. And fire. Successful shot, it seems. Measure that angle. A little bit less than the other one. Okay. Let's get shot number 3 here. Okay. Pulling back the spring gun. Second notch. Reset the bar. Angle bar. Load the ball. And Ready, aim, fire. That was a successful shot, and this is pretty consistent here. Alright, shot number 4. Reload the spring gun. Reload the ball. Ready. Oh, reset that. Shot number 4. Ready, aim, fire. Okay, we got that one successful. Very consistent shot angle here. Okay, make another shot. 1, 2. Dud. Okay, there we go. Load the ball. Reset the marker. Ready, aim, fire. Huh. Okay. Make that measurement. Alright. One more shot to go. I'm going to make 2 more shots just for the heck of it. Okay. And ready, aim, fire. Okay, so we got that angle. That one was a little bit lower, huh? Alright. One more shot for the record. Okay, here we go. Ready, aim. Alright, so that's the last shot. Alright, so you need to calculate the average angle from those shots and then remove the bar, the middle strip here to that average angle. Mine came out to be right there. Average came out to be 19.3, which is right about there. And then we just got to measure the height to the bottom of that tape marker again, black tape marker. And that'll give us the change in height, or from that we can get the change in height of the catcher. So you got to measure that to 3 significant figures and write that down, and then calculate the change in height for the catcher, and then from that you can do the rest of the calculations to predict a shot distance when we shoot it off the edge of the table after we measure the height of the table. Okay, we are now about to move into part 2 of this lab, which is going to be shooting the ball off the edge of the table. But in order to make our prediction, we need to know the height of the ball above the floor. And that's from the instant that it gets shot, so we can calculate fall time. So if you observe the spring gun here, the center of this bar right here is the same height as the center of the ball. So it's easiest to measure the height of the ball by measuring the height of the spring gun, because I can turn it and hang it off the edge of the table here so that we can measure right to the center of this spring gun, which is going to be the height of the ball. Okay, so this is from the floor, and this is almost 85 centimeters it looks like. Make sure the ruler is level here. I'll balance it. And then we need to get focused on the ruler right to the center of that spring gun. Looks like it's going to be about 84.8. Okay. Just a quick thought about the units here. Of course, we are using centimeters for our measurements, but for the calculations, I'd recommend you convert centimeters to meters, because the acceleration due to gravity is always thought of as 9.81 meters per second squared, so it makes sense to convert our measured units to meters. And then so I calculated the predicted shot distance when we fire the spring gun off the edge of the table when the ball falls through the height that we measured, and it's going to go all the way around this white sheet of paper here is the predicted shot distance. Now what we need to do though is get the distance that it travels from the gun, from the end of the gun to the edge of the table, so that we can add that to how far the meter stick is here and get the total shot distance. So the distance from the muzzle of the gun to the edge of the table here, that's what we call D table on the handout. It's coming out to be 40. Edge of the table is right there, 40.7 centimeters. So 40.7 is what we got for the D table here, okay? 40.7 centimeters. And what we got for our predict is up to you to calculate. Then you're going to take, that's the total range that it's expected to travel. That's going to be, you take that and subtract off this distance to the table, then we get the distance predicted from the edge of the table out to the final distance when it hits the floor. So that's what this one is right here. Okay, so this is going to be interesting. See if you guys can tell whether or not it hits the paper. I'm going to try to put some stuff in slow motion maybe for you to see if you can see the ball in slow motion. That would be pretty impressive. Okay, here's the first shot. See if it hits the paper. Ready, set, go. That hit the paper pretty spot on. Now I just got to get the ball under the table. Okay, so let me show you how we're going to keep track of these marks. Alright, I have it all set up to just go ahead and I'm going to make about 10 shots to set up this next shot here. Okay. And shot number 2. Hit the paper again. And go. Oh, that one was actually a little bit farther. Okay, so that might be an outlier. Let's see the paper marks and how we got. Alright, so this isn't just any normal paper stack here where we made our shots. So we have the distance from the edge of the table is 2.1 meters. And you can see where the ball hit several times from the paper, from just the white paper, but we got this set up to be much easier than that even. There's a piece of carbon paper, and then under the carbon paper you can see the marks very easily where the ball was hitting. A bit farther out than I was expecting here. How many marks do we have on that paper? 1, 2, 3, 4, 5, 6, 7, 8. That's weird. I thought there should be more than that. 8 is all we have. Huh. Maybe the ball didn't hit quite as consistently as I thought, or I lost track of the count. Alright, but we can still work with this. I could make more shots, but that's too much effort. Wait a second. That's a fuzzy. Okay, so we got 8 shots, and how are you going to get this final distance? Is simply measuring from the edge of the paper, which was at 2.1 meters, and measuring it to the center of each spot. Oh, I did find where there was another shot. There's a very dim mark right here. And that was actually another shot. It was just on the edge of the carbon paper. It didn't make a very good carbon mark. And I think that's all of them. So that's 9 shots altogether. And so to make these final little measurements, all we need to do is line the ruler up with the edge of the paper here. Okay, to see how we're going to measure these, see how we're going to do these distances, well, 2.10 is the distance from the edge of the table to the edge of the sheet right here that was on the floor. And so now we need to say, well, the distance that the shot went off the edge of the table is going to be 2.10 plus whatever this comes to right here on the ruler. So I'm going to make some lines here to the center of each shot, and then you will make the measurements on the ruler to add up the distance. Okay, so you can see what I did here for you guys to be able to get this extra distance. You can see I drew these perpendicular lines out to the center of the shot. And so you can take, for your D measure, that's what we're trying to get here on the data sheet, is the measured distance from the edge of the table. Your D measure is just going to be equal to, you could say, 210 centimeters plus, for instance, on this bottommost shot, it's going to be 210 plus 10, 11, 12, 13, 14, 15, and you get another significant figure. You could say maybe 14.9 on that one. So it'd be 210 plus 14.9. Alright, now, of course, that would come out to be 224.9. Significant figures, though, would have us round that off to 225 centimeters. Okay, and that would be our first D measure that we would write down here in our table. Okay, 225. Now, you can go through and do the rest of them. The shot number is arbitrary. You can just measure the rest of them. Just freeze frame this. Whenever I had it all lined up, I misaligned the ruler now, but whenever I had the ruler all lined up a second ago, you just go back and freeze frame it and then make all those measurements for each of these shots and get the total added up just like I did here for the D measure. Okay, then you write all your D measures down on the table here, and then you average them, get your average measured distance here, and then your total distance is going to be the distance of the table. That was from the edge of the ball, or from the muzzle of the gun, all the way to the edge of the table. That's what we measured, was 40.7 centimeters. So our total distance is going to be whatever the average is here, plus D table, which is 40.7 centimeters. And so that's going to be, for instance, if our average was the 225, which it's not going to be, you know, but maybe it is going to be 225 on average. I'm not sure yet. 225 plus 40.7, that would be our total actual shot distance, around 260 something centimeters. Okay? And then you can see what the percent difference is. Then you can do the rest of the calculations for this lab, and that's going to be the last lab for the term. Did I just say that? The last lab for the term? Well, not quite right. This is the last lab video for the term. And these videos just take a lot of time to make, actually. So, I hope you enjoyed these videos, and this one in particular, and see you next time. Well, this is not going to be next time.